to go into permutation and combination. Oh my God, this is my favorite topic. Go ahead. Okay. No, you're going to use calculator. In fact, that's a good question. During I said we're going to have a practice question together, right? By practice session, I'm going to tell you what and what you need for the exam. I will allow calculator. Does that make sense? Okay, now I want to go to my favorite, topic. I remember when I was in college, I liked permutation and combination a lot. But let me tell you this, what we're going to do here in the next 20 minutes, we actually want to have a way to select objects in such a way that order matter and order do not. So I'm going to show you how to do that. And I'm also going to show you how to apply both. You could have a question where you're going to apply both permutation and combination together. Now let's get started. We're going to start with the permutation first. Okay. Now, when you are talking about a set of distinct objects, okay, ordering is very, very important. Ordering, order, is very, very important. Now, if I have how many letters, I got 8, right? In how many ways can I arrange that? Of course, that's going to be n factorial. Okay, that depends on the numbers of letters. So that's going to be 8 factorial. Then it means I'm going to get that. Okay, what is the formula for permutation? That's what I'm showing. N permutation R going to be n factorial divided by n minus R factorial. Take a look at that. Now, let's take a look at this example. A club has 9 members. In how many ways can a president, a vice president, and a secretary be chosen from the members of this club? Of course, when you take a look at this, order do matter here. Order do matter. When order do matter, I'm actually going to use permutation. Okay, I got 9. The club has 9, n equal to 9, and they actually want to choose 3, right? And of course, I know the position of the president is higher than the position of the vice president, and that of the vice president probably higher than the secretary. So order matter here. I'm actually going to use permutation formula. All we're just going to do is to plug in all of that so you get a result. Now, this is another one. Okay, from the 20 raffle ticket in the house, 4 tickets are to be selected in order. Look at that, in order. Here you're going to use permutation. Order do matter. Okay, now look at the order here. The order of the first ticket wins a car. The second win a motorcycle, and the third win a bicycle. You can see here the reward of the first is more valuable than the second. You know that, right? So here, order do matter. You're actually going to use permutation. Let me tell you, nobody is going to tell you whether you are working with permutation when we give you a question. Nobody's going to tell you whether you're going to use permutation or combination. You are going to be the one that will figure that out. All what I just need to know is just like, okay, when order matter, it's permutation. When order do not, it's combination. Now we are still under permutation. We call this guy distinguishable permutations. Maybe I have 10 balls. I have 10 balls in a box, and they are of different colors. Some are white, some are red, some are black. Okay, and it's basically going to be the totality. N1 is going to be the number of items of the same kind, like that. So the formula is going to be n factorial divided by each of that factorial. This is what we call distinguishable permutation. I'm going to walk you through an example now. Take a look at this guy now. Okay, find the number of different ways of placing 15 balls in a row. Give it that 4 are red, 3 are yellow, 6 are black, 2 are blue. This is where you're basically going to apply the idea of distinguishable permutation. The totality is going to be 15, right? So it's going to be 15 factorial divided by 4 is the numbers of red, 3 is the numbers of yellow, 6 is the numbers of black, and 2 are number of blue. Any question on that? Super easy, right? Any question? If you get stuck, please let me know. I'm actually going to go by and explain. Okay, now I want to go into combination now. There's a combination when order do not matter. That's why we're going to use combination. And there's a relationship between permutation formula and combination. Do you know that when I divide the permutation formula by arrow factorial, that will give me combination formula? Take a look at that. So C into N comma R, that's a mathematical notation for, combination. Now, can we have an example on that? Oh my God. We solved this problem before using permutation, right? Let us see now. A club has 9 members. In how many ways can a committee of 3 be chosen? Did I mention president, vice president, secretary? Did I mention that here? No. It means any 3 people, members can be chosen. In that kind of situation, order do not matter. I'm actually going to use combination. Any question? So I'm going to use a formula here for combination. Take a look at that. N factorial divided by R factorial into N minus R factorial. All what I just need is to identify what's my N and what is my R. Okay. I believe calculator is going to do the rest. Any question on that? Okay. You really understand that, right? Okay. Now, want to go to the next slide. Now, we have a situation where we consider the number of subsets in a set. If I want to know, there's something that we call power of a set. There's something that we call power of a set. Okay. The power of a set. Okay. The power of a set. The power of a set is just going to tell you the possible number of subsets that we have. In mathematics, the power of a set is just going to be 2 raised to power the cardinality. If I'm talking about set A, okay, 2 raised to power the cardinality. The cardinality of a set is the number of elements you have in a set. Okay, do you know that? When you have different kind of combination together, it's the same thing as 2 raised to power n. Okay, n combination 0 plus n combination 1 up to n combination n is mathematically the same as 2 raised to power n, which is going to be the possible numbers of sets, of subset in a set. Let's have this example. A pizza parlor offers, the basic cheese pizza and a choice of 16 toppings. Okay, how many different kind of pizza can be ordered at this pizza parlor here? It could be, if you want to use that one, it could be 16 combination 0. You don't order anything. It could be 16 combination 1. So it's basically going to be 16, okay, combination 1, 16 combination 2 until you get to 16 combination 16. But this is going to take forever. Because of that, we have a formula. Since we know that it's going to be 2 raised to power n, then it's basically just 2 raised to power 16 instead of us to go all the way. Okay, so that's why you see 2 raised to power 16. It means 65,536 different pizza can be ordered. Now, okay, go ahead. Why? Oh, it's 2 raised to power n. We've showed that mathematically. We've been able to show that is equal to 2 raised to power n. When I don't need to show it in this class, you just need to take it like, oh, okay, it's equal to that. Does that make sense? Maybe in a very advanced class, of course, I'm going to show you how, when we that up, that I is going to be 2 raised to power n. Does that make sense? But all we just need to know now is that, oh, okay, that is 2 raised to power n. Okay, now we have some problem that can also be solved using the products of combinations, products like multiplying combinations. Take a look at this example. A group of 25 campus contains 15 women and 10 men. They are 25. Okay, in how many ways can a scouting party of 5 be chosen? And it must consist of 3 women and 2 men. If you want to choose 3, if you want to choose 3 women, of course, the 3 women will be choosing from 15 women. And 2 men will be choosing from 10 men. So it means at each, if you look at the first one, the numbers of ways of choosing 3 women from 15 women, that will be 15 combination 3. The numbers of ways of choosing 2 men from 10 men, that will be 10 combination 2. If I want to answer the question, all what I'm just going to do is to multiply the result. Any question? Now, this problem requires using both permutation and combination. You be the one that will figure it out. Take a look at this question. A committee of 7 is to be choosing, okay, from a class of 20 students. The committee consists of a chairman, vice chairman, a secretary. Anytime you see that, then the knowledge of permutation is needed in that one. Now look at the question. Look at that. And 4 other members. Look at that. And 4 other members. When they say and 4 other members, you know, you've mentioned those who are officials, okay, that are ordered. I wanted to believe the 4 other members are not ordered. Does that make sense? Now in that situation, it will require the knowledge of both permutation and combination. Oh, wait, how many more minutes do I have? I think I say I have 10 more minutes, right? Okay. Now, we need to, of course, use a permutation knowledge where we want to choose 3 people out of 20. Who are the 3? Those ones that are ordered, right? The chairman, the vice chairman, and the secretary. That will give 20 permutation 3. Now, when I've chosen 3 from 20, how many more people do I have in general? 17. Now, if I want to make any other selection now, I will choose the other 4 members from the 17. And the other 4 members are not ordered, then I'm actually going to use combination. Then I get that result. Then I'm going to multiply out. I get this result. Any question? Okay. This is another one, a group photograph. I don't know whether you've come across, you know, when you are in a party and some people, the guests want to have, you know, picture, and somebody say, okay, I'm going to, maybe there's a couple in the party, or there's 2 friends in the party that are going to say, oh, I want to stand very close to my friend, or I don't want to stand very close to my friend. So how are we going to figure it out? Take a look at this. 12 employees at a company picnic, you know, are to stand in a row for a group photograph. In how many ways can this be done? If A, Jane and John insist on standing next to each other, then how can it be done if Jane and John refuse to stand next to each other? Okay, we're going to get different results. So now I need you to pay attention to the way this is basically going to be done. Now, I said since the order in which people stand is important, I told you, use permutation when order matter. But we can't use formula of permutation directly, right? What are we going to do? Since Jane and John insist on standing together, we're going to count them as one object. Does that make sense? If we count them as one object, okay, don't forget, how many people do we have in a party? Initially, it is 12. Since 2 people insist they're going to stand together, they're going to be counted as one object, which means we now have 11. Now, we now use permutation now, okay? On the 11, that will be 11 permutation 11. So 11 permutation 11 is more or less like 11 factorial. Does that make sense? Now, the other one I say Jane, or now if they stand together, this is not the end. You know, when you get 11 permutation 11, that is not the end. Now you're now going to consider possibility of them standing together. You know, there's possibility maybe this is John and Jane, or they stand this way. Then therefore, how many arrangements? It's going to be in the 2 possible ways. Okay, they can stand together, right? Those are the 2 possible ways. Now you're now going to put the 2 possible ways into consideration. Okay, you will now need to multiply the result that you got before by 2. Where are you multiplying by 2? That very 2 will be the number of possibility that the 2 of them can stand together. So that you have a John here, a Jane here, or the other way. Now, if you multiply, that was why we're multiplying 2 by 11 factorial, and that's actually give us that. Is there any question on how we figure that out? Any question? Okay, the next that we want to do now, what if they don't want to stand together? Okay, now This is the situation. If they stand together, if they don't stand together, when we add them up, that is going to give us the totality. I'm going to say that again. Whether they stand together or they don't stand together, when I add it together, that will give us totality. Now, what is the totality? If I'm not in, if for this we have 12 people, right? What is the possible numbers of where they can stand? That would be 12. That would be 12 permutation 12. That would be 12 factorial, right? This is the totality here. What am I going to do? If I want to get the numbers of ways, if they don't want to stand together, if they don't want to stand together, I'm actually going to subtract when they stand together from the totality. Because when they stand together, because standing together, not standing together is a restriction. That's a restriction. But this guy here, 12 permutation 12 is without any restriction. And we get two possibility of restriction, right? Now, so when you subtract that, that was why we are subtracting that, and you get that. Any question? Any question? Initially, I did not include the material for probabilistic graphical model because it's too complex. But what I'm going to do, somebody has demanded for the material, and I'm actually going to upload tonight the material for probabilistic graphical model. But you know what? What we did in class is enough, even without the material, because the ongoing assignment is very, very crucial. Look at what I gave and what we did in the notes. But of course, I said I'm going to dedicate a section where I'm going to walk you through practice question. Let me tell you, in statistics, we use calculus knowledge a lot. Even though we assume that you have a prerequisite, you've taken calculus before you are qualified to to actually take this course. But you know what? If there is any one of you that is struggling with calculus that we use that we need in this class, please meet with me during my office hour. I'm gonna, we're gonna sit down, then I'm gonna work things out. Okay, I told you the other time, the problem disclosed is problem solved. Even up to this moment, despite the fact that I already have my PhD, I still do research where I make use of calculus, where I say revise my knowledge of calculus. Even though I'm not in mathematics, I'm in statistics, but we need the knowledge of calculus in our work. And that's why, if you look at the practice question that I gave you, now you're basically going to see, particularly when you're working with the continuous random variable, the idea of calculus is required. I posted a video, my last lecture, when I was doing something on the board, I actually recorded the video. When I get to my office, I go through the first principle approach in calculus to determine the values of K for, the double integral. The recording is on the canvas. I normally want a situation. Do you know the only way to know whether you really understand this course? Can somebody tell me what is the true way to know whether you really understand? Is it assignment? No, it's not. You know the true way? You saw it? Exactly. And another thing is, another way that I'm going to know is your performance in exam. And I don't want to wait. Because I know when I give assignment, somebody can, he can go to somebody and say, okay, this is how to do it. But exam. And that is the reason why I'm appealing to you, even me. That's why the fact that I've had all the qualification, I still read. There are some things I still struggle with. And the only way to actually get out of it, the only way is just like when you go over and over and over again with that. Don't be discouraged. Last night I was solving a problem. I didn't get it. You know what I did? I put the problem aside. I was now playing with my children. After some time that we play and they go to bed, you know what I did? I go back to read. When I go back to read, I now saw my mistake. So what am I trying to say? Don't give up. You know, when you try to work things out, it doesn't work the first way, you can still go back to read. By the time you get back to read, oh my God, it may be very, very easy. So like I used to say, do not hide your feelings. If there's anyone in this class who is struggling, you know, I said it, who is struggling, please reach out to me. I know the reason why students don't want to reach out. Maybe they don't want to, they are looking for somebody they can trust. You can trust me. You know why? Because whatever we discuss will be treated with absolute degree of confidentiality. I know the reason why students don't ask questions in class. Maybe they don't want somebody to know that, oh, you are asking that kind of question, but that's no problem. But you can send me a message. Okay. Next week, you know, we're going to start a new topic, and that's going to be on mathematical expectation. And of course, part of what we're going to do next week, of course, you know, is going to be part of the exam as well. Next week is going to be easy because we're only going to be talking about expectations. Does that make sense? Okay, make sure you stay safe. Oh, it's another weekend, right? Make sure you stay safe and have a very good weekend. But for now, everyone. Oh, the guy online. Oh, okay, he's gone. Okay.